Okay, this is Chemistry Unit 4. This is the fourth video of this unit. So we're looking at the arrangement of the periodic table. The periodic table is arranged to show relationships between different elements. Remember Mendeleev, he arranged his periodic table by atomic mass, and he was trying to arrange it in such a way that the relationships between different elements were highlighted. The periodic table is a model used to describe the periodic law. Elements are located in horizontal rows. The rows are known as periods. Remember periodic law, we see repeating properties periodically or at regularly occurring intervals. Vertical columns can be known as groups or families. So just like you may share similar physical traits with your siblings or your cousins, elements and families tend to have similar chemical and physical properties. Elements within a family share similar chemical properties because they have the same number of valence electrons. This is important. Two different families may be very different from one another. For example, compare groups 17 and 18. All of the elements in group 17, fluorine, chlorine, bromine, and so on, are extremely chemically reactive. This is a trait that every family member in group 17 has. Elements in group 18 are the least chemically reactive elements. So these are two families. Within a family, they have their own similarities, and they're right next door to each other, 17 and 18. They couldn't be more different as two different families go. But within a family, we see very similar properties, and it's because of the number of valence electrons. We're going to look at different families now. Group 1 elements are called the alkali metals. Group 1 is at the far left side of the periodic table. The periodic table that is in your binder probably doesn't have group numbers. So when you come back to class, you'll want to write in the group numbers. They are written across the top. They're numbered 1 through 18, left to right. Group 1A is the alkali metals, and just group 1, are the alkali metals. These are the most chemically reactive of all the metals. They are so reactive that they will react with pure water. This family shares a common physical property as well. They tend to be very soft. So soft that some of them can be cut with a butter knife. If you have a neutral atom of an alkali metal, it's going to have one valence electron. So before we go any further, let's flip to page 5, the last page. There's an empty periodic table here, and we are going to label all of the different groups. So the alkali metals are in group 1. They are all of this right here. So we'll label this alkali metals. If you have colored pencils or markers, anything like that, you can color code this. If not, as long as you're careful, it'll be fine if it's all in pencil. So the alkali metals are in group 1, but group 1 contains one other element, which is hydrogen. Hydrogen is not a metal, and it doesn't exactly fit with the alkali metals, but based on its electrons, this is where we put it. So group 1 is hydrogen plus the alkali metals. So I'll make sure that we can see this blue line really well here. Then we have group 2. Group 2 elements are called the alkaline earth metals. Alkaline earth metals. It's a similar term, so be careful not to get the two confused. This is group 2. This family tends to be pretty chemically reactive. I'll say highly chemically reactive, but they're not as reactive as the alkali metals. So the alkali metals, they come in contact with water, they tend to explode or burst into flames or something of that nature. Group 2 elements, they can touch water and not really have an issue. They will react with other things, but they're not as reactive as group 1. A neutral atom from this family has 2 valence electrons. So let's go to page 5. Looking at that blank periodic table, I'm going to make this one red. And these are alkaline earth. I'll say alkaline earth. Alkaline earth metals. Yeah. Okay. So here, we're going to skip over a few places. So we're jumping over to 13, 14, and 15. These are typically referred to by number or by the smallest element in the family. These groups tend to be less reactive, but they do have their own unique group properties. So they're less reactive, but yes, each group has unique chemical properties. A neutral atom from these families will have 3 or 4 or 5 valence electrons, respectively. So that means group 13 has 3 valence electrons, group 14 has 4, group 15 has 5. Since these don't have their own specific names, I'm not going to flip over and label them. Group 16 elements. These are highly chemically reactive. This contains elements like oxygen, which is very chemically reactive, sulfur. Sometimes this is referred to as the oxygen group. So it's the oxygen group. It has a specific name, but I'm not going to tell you what it is. I don't need you to know that. In this family, a neutral atom has 6 valence electrons. Again, we're not going to label that one. We'll come back in a minute. Group 17 elements are called halogens. This is an important group. These elements are the most chemically reactive nonmetals. A neutral atom from this family has 7 valence electrons. Then we have group 18. Group 18 elements are called the noble gases. You know what, before we write that down, let's put the halogens in here. So halogens, I'm going to use, how about orange? Halogens fall in this one right here, group 17. And I'm just going to do the top 4 boxes for now. So these boxes here, this is the halogens group. Okay, so back to the bottom of page 4. Group 18 elements have a name. They are called the noble gases. This family generally does not react with other elements or with other compounds. They don't do much of any chemical reactions. A neutral atom in this family has 8 valence electrons. Let's go ahead and draw it in. I'm going to use black for this one. So everything in group 18, we call these noble gases. It includes helium, neon, radon, some things that you've heard of. So these are some specific family or group names that you'll need to know. These ones, we really just call them by their first element name. It would also be helpful, let's go ahead and number these, and you can do it on your regular periodic table as well. Group 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So these are the 4 specific family names that you'll need to know. But there are also some more broad categories. So at the top of this page, elements can be classified into more general categories than families. For instance, metals share general properties like conducting electricity. They are towards the left side of the periodic table and towards the bottom of the periodic table. Most of the elements up there on the periodic table are metals. The large section in the middle of the periodic table, which is groups 3 through 12, are known as transition metals. These are the elements that we would typically think of when we think about metals. Like the metals that make up our car, the metals that make up electronics, the metals that make up furniture, the steel that supports buildings, all of those things, they tend to be transition metals. So we'll label the transition metals. I'm going to do these ones in black too. So the transition metals are everything in groups 3 through 12. All of this right here. So I'm going to write it in. These are transition metals. There's a separate section at the bottom of the periodic table, and this is the section that I'm talking about. They're called the inner transition metals. The inner transition metals. It's a part of the periodic table, but it is taken out and it's moved to the bottom of the periodic table. If we didn't do that, the periodic table in my classroom would be 12 feet wide instead of being 6 feet wide. Let's go down here. Let's label this. These are the inner transition metals. And where they fit, this is something that you'll see on a lot of periodic tables. There will be a star right here, and there will be 2 stars right here. And you'll see a star and 2 stars. And basically what it is that everything from here to here fits in this one space right here. It would all just be crammed in there. And so you're basically going to insert all of this right here. So those are the intertransition metals. These are things like uranium, plutonium. There's a lot of radioactive things down there. They're very large elements. They're very unstable. And we have nonmetals. Nonmetals are at the top right of the periodic table. Nonmetals show a lot of similar properties. Like, for instance, they are very poor conductors of electricity. And they tend to have solids that are very brittle. So a good example of this is glass. Glass is made of a chemical that's composed of a couple of nonmetals, and they're very fragile. If you were to hit it with, say, a hammer or a baseball, it would completely shatter. And that's what we're talking about with brittle solids. Most of the solids that are nonmetals tend to break very easily if they're hit. We'll come back and label those in a second. Some elements share properties between metals and nonmetals. They're kind of like both. These elements are called metalloids or semiconductors. So metalloids is kind of the old name. Nowadays, the one that we typically call them is semiconductors. These elements, such as silicon, are very important for electronic devices. So these elements, they follow a stair-step pattern. Some periodic tables have it, some don't. On your periodic table, if it's not there, we're going to draw it in pretty soon. And, and so here's where it's going to go. The stair step starts at this corner, right up here by group 13. And it goes down, and then it goes over one. And then it goes down one, and then it goes over one. And it goes down, over. And we're going to go until we'll stop here. So this is the stair-step pattern, and the elements that border on it are the semiconductors. So I'm going to use some dark green here. So boron is a semiconductor. Aluminum is actually a metal. I know it borders the stair step, but it's really a metal. Silicon, this one, filling all of these in, and then that one too. So I'll label these. These are our semiconductors here. So let's label our general things. So we have nonmetals and we have metals. So everything nonmetals, it's all of this stuff over here. These are all nonmetals. And everything to the left of the stair step is metals. So metals tend to be towards the left side of the periodic table and towards the bottom of the periodic table. Non-metals tend to be towards the top right.